Assalamualaikum and welcome to Cambridge Chemistry channel with sarwatAhmed. Be sure to like the video and subscribe the channel. In this video I will discuss paper 1 multiple choice question 970111 May June 2023, time 1 hour 15 minutes. Let's start. Question number 1, element X has 6 more protons than element Y. Which statement must be correct? X has 6 more protons than element Y. Atoms of the elements Y are smaller than atoms of element X. So X has 6 more protons than Y. So it means when Y has more protons than Y, if X has more protons, 6 more protons, then Y, X size of X would be smaller, because across the period atomic size is decreased due to increasing number of protons and same shielding effect. So that's why it is incorrect. Element X has a full shell of electron. X has 6 more proton. Let's say if we assume hydrogen has 1 and then helium, lithium, beryllium, boron and carbon and nitrogen. So hydrogen has 1s1, so 6 more proton, 1 2 3 4 5 6. So nitrogen has 1s2 and 2s2 2p3. So element X has full shell of electron, so there is 1 full shell electrons. Nitrogen and 6 more proton than Y. Suppose this is Y and this is X. Hydrogen is Y and nitrogen is X. Element X and, so this is correct. Element X and Y are in the same group, so the difference between X and Y cannot be in the same group, because difference, like in nitrogen there is 7 protons, and next is phosphorus, there is 15 proton. So 7 and the difference between is the 8. Difference between proton is 8, so that's why this is also not correct. And element X and Y are in the same period. So hydrogen is 1 and nitrogen is in second period, so that's why this is also incorrect. Question number 2, which statement explains why calcium has higher melting point than barium? Calcium cations are smaller than barium cations and have stronger attraction to the delocalized electron. Yes, this is correct, because calcium and strontium are both present in same group. So here calcium and after calcium is strontium. So cations are smaller, calcium cations are smaller than the strontium cations and have stronger attraction to delocalized electron. So calcium has 4 shells while strontium has 5 shells, so that's why size of cation is larger than calcium. So that's why calcium has stronger attraction to the delocalized electrons. So this is correct. Why it is incorrect? The structure of calcium is partly giant molecular, so this is, calcium is a metal, so called calcium is giant metallic lattice, so that's why it is incorrect. There are more delocalized electrons in calcium than in barium, as it has lower ionization energy. there are more delocalized electrons. So valence electrons, there are more delocalized electrons in calcium than in barium, as it has lower ionization energy. Delocalized electron, because both are present in same group. Over here barium, these elements are present in same group, so that's why not more delocalized electrons. It has two electrons which are delocalized in the group 2, so that's why it is also incorrect. There is a greater repulsion between barium atom, as they have more complete electron shells than calcium atoms. So there is no greater repulsion between barium atom, as they have more complete electron shells than the calcium atom. Barium has 6 more shells, so that's why So question number 3, there are 3 statements about potassium and chlorine, and the ions are listed. The atomic radius of potassium atom is greater than the atomic radius of chlorine atom. Potassium atom is greater than the atomic radius of atomic radius in period increases across the period. Atomic radius of element increases across the period, decreases across the period. So that's why atomic radius of potassium atom is greater than the atomic radius of chlorine atom. And you know that potassium is present in group 4 and chlorine is present in period 3. Potassium is present in period 4 and chlorine is present in period 3. So that's why atomic radius of potassium, so there are 3 shells in chlorine and 4 shells in potassium atom. So that's why potassium atom has larger atomic radius than the chlorine atom. This is correct. The first ionization energy of potassium is greater than the first ionization energy of chlorine. So ionization energy is increased across the period. So potassium is present in fourth period, and chlorine is present in the third period. The first ionization energy of potassium is greater than the first ionization energy of chlorine. So potassium has 4 shells, so that's why there is less attraction between the nucleus and the valence shell electron. So potassium has 4 shells, so that's why there is less attraction between the potassium nucleus and the valence shell electron than nucleus of chlorine the nucleus of chlorine to the valence shell electron, because it has 3 shells, so that's why it has greater ionization energy, first ionization energy of chlorine than potassium. So potassium is in group 1 and this is in group 7, and if we look at the trend in across the period ionization energy is increased, so that's why this is incorrect. The ionic radius of potassium ion is greater. Ionic radius of potassium ion is greater than the ionic radius of chloride ion. Ionic radius of potassium is the positive ion, and positive ion cationic radius is smaller than the potassium atom, while anionic radius is greater than the parent atom. So chlorine is to form chloride ion, so anionic radius is greater than the chlorine atom. So that's why it is also potassium ion is greater than the ionic radius of chloride ions. So it is also incorrect. So the option A is correct option. For which equilibrium do both the equilibrium constant Kc and Kp have no units? So first option is correct because Kc is equal to Hi concentration of Hi, H2 and I2. So the mole per dm cube, mole dm cube inverse 1, inverse 3, mole so that's why it has no unit. Kc has and Kp also has so this is also correct. So this reaction A option is correct. N2 NH3, in case of N2 NH3, Kc is equal to 2 ammonia mole dm cube twice mole dm cube thrice. So this is correct, and this is incorrect because in this case mole dm reduced to 1, so this is cancelled out and this is reduced to from 3 to 2, so that's why it is incorrect. And similarly uneven concentration, over here there is 2 mole per dm cube and over here only 1, so 1 is cancelled out and there is unit of Kc and Kp in this case, and similarly there is unit of Kc and Kp in this, only 1 mole per dm cube in this case and mole per dm cube into mole half mole dm cube. So this is also incorrect. So next question is question number 5. Calcium carbide reacts with water as shown. The data below the equation show in kilojoule per mole the standard enthalpies of formation of the compounds involved. Calcium carbide formation is delta HF of all these reactant products are given. What is the standard enthalpy change of the reaction? So this is the reaction: calcium carbide plus water to form CaO to form C2H2. So by using this Hess cycle, so here what is standard enthalpy change of reaction? H delta HR. So we know that this is the elements, compounds and compounds. So element calcium to form calcium carbide, hydrogen to form water, and carbon to form C2H2, and there is 2 carbon atoms, so that's why 2C. So this is the first root and this is the second root. So first root is equal to second root, so this is minus 60 minus 60 minus 286 plus x is equal to minus 635 plus 228, and after calculating these values, we get B option is correct. Question number 6. In sodium chloride lattice, the number of chloride ions that surrounded each sodium ion is called the coordination number of the sodium ion. What are the coordination numbers of the sodium ions and chloride ions in the sodium chloride lattice? Sodium chloride is a cube lattice, and in cube there are each sodium ion is surrounded by 6 chloride ion, and each sodium ion is surrounded by 6 chloride ion, and each chloride ion is surrounded by 6 sodium ion. So that's why coordination number of sodium ion is 6, and similarly coordination number of chloride ion is 6. So that's why option C is correct option. Next question. Histidine is an amino acid, and the compound structure is given. What are the approximate bond angles 1, 2 and 3? We know this is 1, 2 and 3. So bond angles, this is the trigonal planar, and bond angle between trigonal planar is 120. Number 2 is also trigonal, nitrogen has one lone pair, so that's why 3 nitrogen is surrounded by 3 other atoms. So the bond angle is the shape is this one lone pair is there and 3 surrounding atom. So the bond is going to reduced when lone pair is there with any central atom, so bond angle is reduced. There are no lone pairs on carbon atom, so that's why bond angle is 120, and this is trigonal planar structure, and this is the shape of ammonia is, so this is trigonal planar, and the nitrogen pyramidal, trigonal pyramidal, and the bond angle is 107 degree. And similarly this carbon is surrounded by 4 different atoms, so the shape is tetrahedral and bond angle 109.5. so that's why B option is correct, 120, 107, 109.5. Question number 8. The contact process take place at pressure between 100,000 Pascal and 200,000 Pascal. A catalyst is used, 1 to 2 atmospheric pressure. Catalyst is used. Which statement is correct? A vanadium 5 oxide catalyst is added to increase the equilibrium yield of the reaction. Catalyst does not increase the equilibrium yield of the reaction, only speed up the reaction by lowering the activation energy. Changes in pressure have no effect on the position of equilibrium. So changes in pressure does affect the position of equilibrium, so that's why it is also incorrect. The equilibrium yield of the reaction is very high under the conditions used. Yes, these conditions are compromising conditions, so that's why equilibrium yield of this reaction is very high under the conditions used. An iron catalyst is added to increase the reaction. Iron is not used in contact process making sulfuric acid, so that's why C option is correct option. Question number 9. Bromine reacts with aqueous sodium hydroxide at 25 degrees centigrade. Bromine reacts with aqueous sodium hydroxide 25 degrees centigrade. Reaction 1. Bromine plus sodium hydroxide form NaBr, NaOBr plus H2O. The NaOBr is unstable at 25 degrees centigrade and react further. So this is form NaBr and NaBrO3. So which reactions are disproportionation reaction? So bromine over here 0, NaBr minus 1, and NaOBr is equal to 0, Na1 plus oxygen minus 2 is equal to bromine x is equal to plus x is equal to 0. So this is equal to minus 1 plus x is equal to 0 where x is equal to plus 1. So B are carrying plus 1. So this is also disproportionation reaction, and in reaction to NaOBr over here mine plus 1 and NaBr minus 1 and NaBrO3 is equal to 0 plus 1 minus 2 1 plus x minus number of atom 3 minus 2 is equal to 0. This is plus 1. So plus 1 is so this species is also reduced and oxidized as well. So which reaction? That both reaction 1 and reaction 2 are disproportionation reaction. This is also correct. Question number 10. Which statement is correct? The relative atomic mass of chlorine is 35.5. So chlorine is 35 and there is another isotope chlorine 37. So the relative atomic mass of chlorine 35 is not 35.5. Chlorine atom is 30, so that's why it is incorrect. The relative formula mass of calcium carbonate is 100.1. So this is correct option, because 40 plus carbon 12 plus oxygen 16 into 3, this is equal to 100.1. So the answer is B. The relative isotopic mass of magnesium is 24.4. So this is also not correct. The relative molecular mass of O2 is 16. This is 32. This is also incorrect. Iodine and propanol react according to the following equation. If the concentration of propanol is increased, keeping the total reaction volume constant, the initial rate of the reaction also increases. If the concentration of propanol is increased, keeping the total reaction volume constant, the initial rate of the reaction also increases. So by increasing concentration, rate of reaction is increased. So what could be the reason for this? A greater proportion of collisions are successful at higher concentration. A greater proportion, the particles are further apart at higher concentration, is incorrect. The particles have more energy at higher concentration. There are more collisions per second. So this is correct option. There are more collisions per second between particles at higher concentration. So that is the reason to increase the rate of reaction. D is correct option. 4 successive ionization energy of element E are shown. Element E is in period 3 of the periodic table. The fifth ionization energy 16 1000, this is 20,000, this is 24,000, this is 29,000. So there is not big jump, there is also not big jump, there is also not big jump. So in which group of the periodic table is E? So there are 4 electrons are removed, and 4 electrons there is not big jump in between these 4 ionization energy, so that's why might be present in group 14. But why could not be in 15? Because in valence shell in 15 5 electrons are present in valence shell, so there is not big difference between 5th and 6th electron, so that's why it could not be 15, it could not be 16, because there is not big jump between 6 and 7, because in group 16 6 electrons are present, so that's why it is also incorrect. D is also incorrect because there is also not big jump between 7 and 8 electrons, so that's why 14 is correct. In this question you should assume that the gas form behave as an ideal gas. 1.7 gram sample of magnesium reacts with 50 centimeter cube of 2.2 mole per dm cube of HCl at 303 Kelvin and 400 Pascal is the pressure. Which volume of gas is produced measured under these conditions? So we have this reaction magnesium, and we have two quantities, 1.7 gram sample of magnesium. So calculate the moles of magnesium. We have 0.07 mole, and mole of HCl 1000 50 is the volume into concentration, and 50 divided by 1000 because volume is in centimeter cube. The mole are 0.11. So here is 1 mole and 0.1 mole. So hydrogen HCl is 2:1, and there is 0.0 because HCl is a limiting reactant, and magnesium is excess, because for 1 mole it is 0.07 mole, and for 2 mole 0.11, which is equal to 0.0555. so this is the mole of hydrogen gas. Now we using this formula, PV is equal to nRT, because the gas form behave as an ideal gas. PV is equal to nRT, or volume is equal to nRT over P. By using these values, 0.055 into 10 8.31 is the gas constant, 303 is the temperature in Kelvin, divided by pressure. So volume is equal to 1.25 into 10 raised per 2 minus 3 dm cube. So this is equal to 1.25, that is nearly equal to 1.3. so this answer is correct option. A is correct option. Question number 14. Chlorine dioxide react with aqueous sodium hydroxide to produce water and a mixture of two sodium salt NaClO2 or NaClO3. What is the mole ratio of NaClO2 to NaClO3? So the reaction between ClO2 plus sodium hydroxide to form NaClO2 plus NaClO3 plus water. So by balancing this reaction 2 over here, 2 over here, we have 1:1 ratio between NaClO2 and NaClO3. So that's why C option is correct option. The temperature of the sample of an inert gas is increased. What effect does this have on the number of molecules with the most probable energy on the number of molecules with higher energy? What effect does this have on the number of molecules with the most probable high energy and on the number of molecules with higher energy? Inert gas when temperature is increased. with the most probable energy is decreased, number of molecules with most probable energy is decreased, while number of molecules with high energy is increased. So B option is correct option. Question number 16, for which compound is there the greatest percentage loss of mass on strong heating? So calcium anhydrous calcium carbonate, only carbon dioxide gas is produced, and in magnesium carbonate also carbon dioxide is, but in case of calcium nitrate and magnesium nitrate, two gases are produced which are evolved, so that's why loss in mass is more in nitrate salt than carbonate. So these two options, we reject these two options, A and C. Now between B and D, compound is the greatest constant percentage loss. The greatest percentage loss, for example, calcium nitrate gives magnesium oxide, nitrogen dioxide and oxygen gas. So by calculating 100 is the mass greatest percentage loss. So 100 divided by 148.3 is equal to 27.17. So this is the mole of 100 divided by 148.3. 148.3 is the mR of magnesium nitrate. The mole ratio is 2 and the mass is 2 magnesium oxide. These two are gases which escapes. So the mass is mole is 0.6743 and we have same mole ratio. So the mass of magnesium oxide 27.17. So if we have 100, mass is 100 minus 27 point, and total mass is 100% into 100. So if we subtract 27.17 mass from the 100 is equal to, and this is cancelled with this, and the mass is 72.8, which is so this is 72.8. So similarly we solve calcium nitrate, but this is lower than this value, so that's why magnesium anhydrous magnesium nitrate is correct option. The solid sodium chloride and sodium iodide both react with concentrated sulfuric acid at room temperature and room temperature. With sodium chloride, products are NaHSO4 and HCl. With NaI, products are NaHSO4, HI, iodine, sulfur dioxide, water, sulfur and H2S. What is the explanation for this difference in products? Chloride ions will displace iodine from the solution. So this is incorrect, because chloride ions cannot displace iodine from the solution. Iodine is less reactive than chloride ion, so chloride ion cannot displace iodine. Hydrogen chloride is more volatile than hydrogen iodide. So in this reaction volatility does not matter. So iodide, this is the chemical property, and volatility is the depends on the number of electrons. So hydrogen chloride is more volatile than hydrogen iodide. HCl is more stable than HI. So that's why this is incorrect. Iodide ions are better reducing agent than chloride ions. Yes, this is correct option because reducing power is increased down the group. So that's why iodide ions are better reducing agent than chloride ions. And chloride ions cannot reduce further into, because HCl is a strong oxidizing agent than sulfuric acid, so that's why it cannot reduce. So iodide ion are strong reducing agent, so that's why it is iodide ions reduced further sodium hydrogen sulfate into uh, the products are sulfuric acid into sodium hydrogen sulfide, HI, iodine. All these products are possible with the iodide ions. Sulfuric acid is able to act as a dehydrating agent with sodium iodide. No, sulfuric acid is able to act as an oxidizing agent with sodium iodide. Silica has a melting point of 1713 degrees centigrade. It reacts with hot sodium hydroxide to form sodium silicate and water. No reaction occurs when silica is added to hot sulfuric acid. What can be deduced from this information? No reaction when silica is acidic oxide, so cannot react with hot sulfuric acid. What can be deduced from this information? Chemical behavior of silica: amphoteric, not amphoteric. Silica is giant molecular structure. Amphoteric, simple, not simple, giant macromolecule. Chemical behavior of silica is acidic, and acid is giant macromolecular structure. Acidic but not simple, so that's why C option is correct. Element X has the second largest atomic radius in its period. An atom of X has 3 occupied electron shells only. X has the second largest atomic radius in its period. The oxide of X is shaken with the water. What could be the pH of resulting solution? So atomic radius decreased across the period, so that's why element present in group 2 has the second largest atomic radius in its period. So group 2 are metals, and metals form if oxide of metal form basic oxide, and the oxide of X is shaken with water. When it is shaken with water, the solution will be alkaline. So what could be the pH of the resulting solution? X has 3 occupied shells, so that's why element X is present in third period, so this could be magnesium. So magnesium oxide is when shaken with water, so slightly soluble in water, and its pH would be 9. So that's why C option is correct. Which emission from an internal combustion engine contributes to the erosion of marble statues? Carbon monoxide, neutral. Nitrogen, also neutral. Nitrogen dioxide, when react with the water